I'd like to introduce Mr. Jeffrey Snover. Jeffrey?
Howdy. So I'm Jeffrey Snover. I'm a distinguished engineer, and I was the lead architect for Windows Server 2012, and I hope you liked Windows Server 2012 because now I'm the lead architect for Windows Server and for System Center Data Center products. So if you like what you saw before, you're going to see more of that coming to you. So today we're talking about transforming the data center. What's that all about? We like to talk about the Cloud OS. And so the whole TechEd is about describing and enumerating that thought. What is a Cloud OS? And this vision of the three data centers. See, unlike the others, Microsoft has this vision of allowing you to choose the cloud and deal with the cloud on your terms. It's not a one cloud fits all strategy. It's a three cloud strategy. We have one unified platform that can then be deployed in a number of different options. It can be run on the customer's site, on your site, where you have maximal control. You can control what hardware you run it on, you can control the latency, you can control who has access to the physical servers. You can run our software on a service provider cloud, where they can provide maximum customization, running on their hardware, offering you value-added services. Or they can run on the Azure cloud, on Microsoft's cloud, where you have maximum scalability, geolocation. You get to decide where in the world you want your stuff to run. And so it's one cloud OS running in these three deployment options. Now, the Cloud OS is not a product. You can't go look in the catalog and say, I want to buy one of those. Rather, it is our vision for this unified stack. And so what you will see is, step by step, we'll fill out that vision and show you how to adopt it. And that's what this TechEd session is all about. And so the Cloud OS gives you these things. We're going to focus in on transforming the data center. At the heart of the transforming this data center is really quite simple. There are two things. First, complexity and cost, they're the enemies. You will see us focus in on eliminating these two things. That's why we put them in red. Red's bad. Next, that abstractions need to be integrated. And let's talk about that. Okay, so what this means is, in terms of reducing cost and complexity, we're taking an approach of leveraging standards-based management to deliver this idea of data center plug and play. Now, how many of you ever tried to plug in a CD-ROM the first time it came out? I was one of the early adopters, and I thought I was so cool. I got a CD-ROM, and 2 days later, after many tears, bent paper clips and dip switches and IRQs and IOs, it was just a horrible experience. But I got that thing running. And now, that's not the way it works. Now the way it works, in fact, a couple of weeks ago, my boss told me about somehow he got a CD-ROM. He said he had an Ultrabook, he didn't know what to do with it, right? Ultrabooks don't have CD-ROMs. So we went to a store and he just bought one, and it could have been any store, he just bought it, he plugged it in, the system discovered that device, found out what it was, brought the appropriate software to bear, and then made it available to him. He put the CD-ROM in, played his music or whatever, and he was a happy guy. So what really happened there? And the answer is the magic of software transformed what was a hideously complex and difficult experience into a plug-and-play experience. An experience where it just works and you're able to consume the services. And we're going to do that for the cloud. By the way, we did it for the PC, we did it for enterprise software, and now we're going to do it for the cloud. The great thing about this is then that produces a world where you know that the products, you can just buy the products and you know that they're going to work. Look for the Windows logo, those are the products you're going to be able to plug in and just work. Now, the other thing Microsoft does is we do this on high volume components, right? That's the magic of Microsoft. Microsoft has been able to take very high-end complex stuff, we simplify it, we get it running on high volume components, which means low prices, which drives adoption, which drives volume, which lowers prices. We call this the virtuous cycle. Again, we did it for the PC, we did it for the enterprise, now we're going to do it for the cloud. And this idea of the right abstraction. Now, a lot of our competitors will talk to you about the cloud, and they view the cloud as something you bolt on top of an irrelevant operating system. We fundamentally disagree with this thinking. It is wrong. The cloud is a classic operating system problem. Operating systems, lots of technology, they have two missions, two simple missions. They abstract resources for multiple consumers, and they provide services to applications. So when we talk about a cloud OS, we mean we execute those two missions in the context of a data center instead of in the context of a single machine. And that's why the standards-based management, we call that the data center abstraction layer. The hardware abstraction layer was for a single server. The data center abstraction layer is for the entire data center. And because we take this approach, it allows us to solve the right problem in the right way, at the right layer, to give you the best performance, the best cost, etc. Ultimately, the goal here is to shift IT resources from planning and evaluation and deployment and debugging to a world where you look, you figure out what you want, you plug it in, and you go. So you focus in on adding new capacity. So we like to refer to this as a cloud plug-and-play. And in fact, we have three cloud plug-and-play stories. The first is all focused in around devices. And devices, be they phones, tablets, PCs, from Microsoft or from other vendors. Cloud plug-and-play allows you to just plug those devices into the cloud anywhere, anytime, and they just work. You get access to your data, your people, and your resources, your data, your applications, and your contacts. Okay? And this dramatically simplifies your life. The next is focused in on applications, whether they're Windows applications or Linux applications. You'll hear a lot about our great Linux support. You plug these applications into the cloud, on-premises, on-prem, service provider, or Azure, and they'll just work. Dramatically simplifies application deployment. Or the third is focused in on resources, be they servers, top-of-rack switches, network devices, storage. You plug those into the cloud, and they just work. That you're able to simplify fabric administration of the cloud.
It's time, Jeffrey. It's time to virtualize every workload. Quite simply, we've moved to that. We've been there for quite a while now. Server 2012 really exemplified it, and we're now going to raise the bar even further. There's no reason why you can't and shouldn't be virtualizing everything out there. It's time to rethink storage. Storage right now is about cost, it's about complexity, it's about a tremendously difficult management experience. Whenever I talk to a customer, one of the first things I always ask them about is, tell me about your storage. Who's your storage vendor? And I say that smiling because no one ever gives me the one answer. They always have at least two storage vendors, usually more. And what that translates is to, I've got some storage over here, I've got some storage over here, I've got some storage over here. By the way, it's completely siloed. We don't manage any of it in any way efficiently, and we don't even know what we have. So that's a real challenge. It's also time to simplify networking. Networking has been just this tremendously difficult thing. You heard Brad actually mention this in the keynote today. On Azure, we deliver over 50,000 network changes a day. Do you seriously think humans are involved with this? There's no way that humans are involved with this. You define the fabric, you define the policy, and you let the fabric do the work. It's time to get us error-prone humans out of the way. When you see when someone's having a major cloud outage or a network, take a look, and was it someone that was actually fat-fingering a change into a router or into a switch? We got to get away from that. It's time to simplify networking. So when it comes to virtualization, we're building off already the incredible things we did in 2012 in the Server 2012 R2. We already have an integrated high-performance virtualization platform, but we always are listening to you. I cannot tell you how important is your feedback. And I also want to thank you, because we know you guys are adopting 2012 very quickly. Hyper-V is at the top of the list, and we're sitting back listening going, what is it you need next? Well, here's what you've already told us. Number one is reduce complexity, reduce cost and downtime. Keep doing that. Okay? I just showed you the Spaces keynote in the demo in the keynote. Big part of that is about reducing that complexity and cost. Provide easier deployment and support lifecycle of workloads. Provide flexible virtualization platform for maximum agility. A lot of people forget that the cloud is very much about agility. When I just did disaster recovery with Hyper-V Recovery Manager, folks, did you really think about and internalize just how quickly we did all of that? I mean, it was amazing how fast, and that is all done because the cloud gives us that agility. Well, we're responding with a whole bunch of key new capabilities. Cross-version live migration. I want to make it easy. I want to provide you a no downtime upgrade of your cloud infrastructure. I can literally drag and drop VMs now from Server 2012 to Server 2012 R2. And you can take advantage of all those cool new storage features I showed you, tiering, deduplication, and more. Online VHDX resize. Now you can dynamically resize your virtual disks on the fly while the VMs are running. I'll show that to you in a few minutes. Automatic VM activation, live VM export cloning. I love live VM export cloning. This one's actually really cool, and this one's actually about solving hard problems. Think about this. Have you ever had an application that just goes dead? And you get one of those, well, it's gone dead on the network. We're not sure what's going on. We don't know if this is a transient problem or if this is a recurring problem. So what do? Well, you're forced with two options. You can reset the VM, reboot the VM, and hope it was a transient problem that doesn't come back. Or you can take the VM down offline and go take a look at it and see if there's a real problem. Of course, that means downtime. So neither option is good. We want to give you a third option. That's what live export and cloning is all about. Because now I can live clone the VM, I can reset the VM, can have it continue to run, but now give an exact copy to my test and dev guys to actually go look at it. Let's go take a look at the logs. Let's go debug it. In fact, there's a problem. We introduced a patch the other night. Let's go fix it. Let's test it in the offline version and then roll that fix into production. So it's about solving those really difficult problems. It's also about flexible virtualization. I showed you live migration compression.
Dude,
it is awesome.
You're really not going to pass over VM remote access by VM bus, are you?
All right.
That's awesome.
Remote access, you're totally right. I got to be careful. We've got very little time and a lot of demos. I want to get to the demos.
Okay.
But remote access via VM bus is actually really sweet. Here's a good example. You got a VM running in the cloud, and again, it goes dead. You actually caused the problem. You went in there and made a change to your firewall, and you can no longer have network access to your VM, so you can't RDP to it. How do you solve that problem? That's a really hard problem to solve. The way we're going to do it was actually going to provide you remote access via VM bus. I can now remote into a VM, give you full console access without network access to the VM. I can debug a VM that has crashed. I can access a VM that doesn't even have an OS installed on it.
Yeah,
and do this remotely. Oh, tell me this isn't sweet.
This is crazy cool stuff.
Yeah.
You got to come down
All
to
of
the
a sudden,
demo and see
the light
it.
just went on, and a whole bunch of people are like, holy cow, yeah. Really hard problems we're solving in this release. Live migration with compression, live migration with RDMA, more robust Linux support, dynamic memory for Linux, hot online resize for Linux, file consistent snapshots for Linux. Folks, we are very, very clear and consistent about having great support for Linux. All right. Changing the game in storage. So again, I talked about this in the keynote, but very much we're focused on providing maximum performance, scalability, and resiliency at minimum costs. Today, we've been honestly, to get massive IOPS, it's always been, well, you're going to have to roll in hundreds and hundreds of disks. We want to take advantage of the latest enhancements, and SSD is that piece of technology, honestly, I feel like I've been waiting for like half my life. A few months ago, I found my old hard disk, a 20 megabyte Atari ST hard disk. Never forget, I bought this for $700. I brought it home, showed my mom. She started screaming at me in Spanish. And she said, I don't even know what this thing is. It's got a little blinky light on the front. And you spent how much money on this? And I found it in my garage. And the point is, between now and up until recently, hard disks have been exactly the same. In fact, I can go all the way back to the 1950s. A hard disk is basically a head crossing a platter that's spinning. Sure, the platters got faster, the heads got a little bit faster as well, but we've still been limited by the head access. Now with SSDs, we're talking about ridiculous IOPS performance, and we want to tap that capability and drive down the cost per IOP. And that's what we're doing with storage tiering and deduplication, as well as additional resiliency options, better control, and again, maximum utilization of your storage. So this is what I just showed you, storage tiering. We're really excited about this because, again, we're talking about taking capabilities you're used to spending 5, 6 digits for in your storage appliances. Guess what? This is simply built into storage spaces, and now you can put this behind the file server, and you have a rocking, super high-performance solution. Again, I just showed you over 124,000 IOPS out of 24 disks, 20 disks and 4 SSDs. Good luck trying to meet that at the price point we're talking about. So we're doing some fantastic things in storage. And because I showed you that in the demo and the keynote, and I provided you the slide here, I'm actually going to bring up Matt now. We're going to show you some other really cool things, because we already showed you not tiering. We're not going to show it to you again, because we have so many other things that we're doing in terms of storage agility and performance. So, Matt?
Thank you, sir. Thank you. Good morning. Good morning. There we go. Thank you. So, as Jeff talked about, we've done some phenomenal stuff in storage in Windows Server 2012 and subsequently in R2. And tiering that we showed this morning in the keynote is just one example of a feature that drives increased performance, but there's others that drive resiliency and reduce costs, all using commodity hardware, commodity storage. And what I want to show in this demo is how we start to create and manage some of that storage within System Center. So what we've got on the screen here is VMM, which many of you may be familiar with, Virtual Machine Manager. And if you're familiar with the 2012 or SP1 releases, you'll know that we manage the fabric, the servers, the networking, which we'll touch on later, and the storage. Now, as part of this demonstration, I'm going to provision a new storage infrastructure for our key workloads. So I'm going to create a file server cluster. And what we're going to create as part of this is a file server cluster consisting of 2 nodes connected to some shared JBOD, so low cost, low complexity, easy to manage through VMM, and that's going to provide the backbone for the storage of our virtual machines, virtual disks, and relevant files. So we'll give this a name, and we'll give the cluster file server a name as well. And we'll go next. And this is the first big choice that we have to make. Have I got some Windows Server 2012 R2 machines already racked and stacked and ready to go that I can configure optimally to run as the file server cluster? If I have, I'll go with option number 1. If I haven't, and I've just got some bare metal servers that aren't configured, I could choose the second option. Provision bare metal computers using a profile that we've defined in VMM, a file server profile. What's going to happen here is we're going to wake those servers up, we're going to deploy a virtual disk down to those physical servers, configure boot from VHD, that machine's going to come up, we're going to configure optimally with the relevant file services, roles and features, and we're going to bring it into VMM's management and start providing a storage platform for our key workloads. So, we'll select that option, we'll go next. To wake this machine up and communicate out of band, I need to integrate with the baseboard management controller. So I'm going to select the credentials to enable me to do that using a run as account in VMM. And I've got a couple of protocols that I can use to communicate. So I can specify that specific to my environment. We'll go next. And now I need to discover the relevant servers out there. I could supply a different range. I could supply a specific IP address. But I'm just going to look for the IP range that I know. I'll use copy-paste. Don't want to be a slow typer. There we go. We'll go next. It's going to search. It's going to discover. And I'm going to pick the 2 machines, the 2 currently off physical machines that I'm going to deploy this particular file server role to. And notice down here this option, skip deep discovery. That's going to save me a bit of time in the demonstration. But what that would enable in the real world is actually a waking of the server, a booting into a WinPE customized environment orchestrated by VMM. It's going to collect information about that particular physical machine and fill in some of this missing information here around the CPU, the memory, the network adapter config. But we can proceed without that for now. So I'm just going to give these 2 machines a name. And I can go next, and I can go ahead and I can go and create that. And I know a feature that Jeffrey particularly likes is this view script, which if you've not seen it, generates the PowerShell. Woo! Generates the PowerShell that I can take, I can reuse going forward in the future if I want to start to automate this in a little bit more aggressively. Now that's going to take a little bit of time to wake those machines up and deploy those. So I'm going to go true cooking show style to one I created earlier. And this particular scale-out file server that we've built, this clustered file server, it's 2 nodes, just like the one we were going to create there. So you'll see I've got 2 nodes. But the whole point of a scale-out file server is to be able to scale out. So in case there's increased demand from virtual workloads that need more file server nodes at the front end of my storage, then I can simply add additional file server nodes and expand this out. So I can meet that change in demand in our cloud. But let me cancel out of there, and let's look at our storage specifically. Because I said earlier that our cluster nodes are going to be connected to some shared JBOD. Low cost, low complexity. But how does that get presented to those file server nodes? Well, it gets presented as a selection of individual disks. And we need to do some clever stuff with that. So we pool them together using the technology built into Windows Server. And you'll see here we've created a pool. There's currently 6 disks as part of that pool. And we can very easily scale out the capacity of our particular pool by adding additional disks. So very flexibly, all within VMM. But there's one little box that I want to draw your attention to, which is incredibly important. And it's this little thin provisioning alert box here. Because what that's going to do is help me, if I am thin provisioning my storage spaces, if my storage spaces start to fill up with virtual disks or files, I want to make sure that I'm not consuming more than I've actually physically got under the covers. And that little alert there is going to help notify me if I'm starting to encroach on that capacity. It's here in VMM. It'll be registered in Ops Manager as well if you're using the monitoring and management packs within OpsMan. So awesome stuff. So we've got our pool, we've got our capacity, we've got our clustered file server, but we're not providing it to any Hyper-V hosts. So I need to create a file share for me to do that. So I'll create file share. I'll select the file server that I'm interested in, the one we created. I'll call it Mat Share. We'll select our appropriate classification, and I'll select a size for this file share. We'll call this one 20 gig, that's fine. And we'll create. And that's going to go ahead and create a file share on that particular clustered file server. So that's a resilient file share that we can then very easily, by selecting a host and the properties, we can very easily assign that particular file share to our particular host. That'll take a few minutes to come up, but we'd select the file share path, we'd go OK, and we'd ACL that from VMM to that appropriate Hyper-V host. That's awesome stuff. So what we've seen there, in a very quick demonstration, in a relatively small number of clicks, we've built a clustered file server from VMM. We've talked about scaling out capacity and the number of file server nodes. We've deployed a file share, and we've managed the permissions, the ACLs associated with that share that we've pushed to that particular Hyper-V host. Ready for our workloads, ready for our virtual machines. Phenomenal stuff, all built in to Windows Server and System Center. Awesome. Back to you guys.
Fantastic. Now, one thing to think about real quickly, you just saw him do all the storage. Don't forget that Virtual Machine Manager already does your bare metal provisioning for your Hyper-V host as well. So you could literally now roll in your rack of servers, have this do all the bare metal provisioning of your Hyper-V host, and now you can have it do the provisioning, bare metal provisioning of your scale-out file server without ever touching the hardware, all from System Center Virtual Machine Manager. Incredibly powerful. Thank you, Matt.
Yeah, you know, if you think about our 3-cloud strategy, Azure has amazing storage capabilities with incredibly low operational costs. And so what you're seeing here is we're using Windows Server, the next round of products, to be able to bring you similar capabilities that you can deploy in service provider clouds and on-premises clouds. Storage technology that gives you maximal performance at minimal costs with very simple IOPS and operations, or a very simple operational model. I'll tell you, our storage stack has been revolutionized and can dramatically change your corporation's cost structure for computing. You all deserve it. You all should be paying attention to this and doing pilot programs and really get this area in focus. You owe it to yourselves. Now, we talked about the storage. We're going to do the same thing in networking. Now, a lot of people talk about software-defined networking, and I don't know about you, but it's a very complex story. Well, what did I say at the beginning? Our enemies are cost and complexity. Our network virtualization story is all about simplification. All right? So this is about being able to say, hey, imagine the case where I've got a set of servers that I've decided to stop running on-premises but run in a software-defined network. Well, how do you get that going? Do I have to change all my IP addresses, etc.? And what if Jeff decided to do the same thing, but we had the same IP addresses? How does he run his stuff? How do I run my stuff on the same machines, even though they're using the same IP addresses? That's the magic of virtual networking. And so our model is that you'll set this up, and our software-defined networking technology will dramatically simplify your world. It's not about you becoming network experts. It's rather about setting things up and then having software that gives you the agility to say, I want to run things here, I want to run things there, I want to move them back and forth. So with that, Matt's going to show us a demo.
Yep. Excellent, thank you. So, again, we've focused on reducing that complexity. We want to help you simplify your physical network, but still achieve the levels of isolation for your workloads on top of that that you need. And network virtualization is going to help us do that. Embedded within Windows Server 2012 and 2012 R2 is the network virtualization technologies that are managed by System Center. And what we see in VMM here is a view of our VM networks, so our network virtualization in play here. And I'm going to show you shortly how we create those VM networks and how simple it is to deploy new VM networks for new workloads and new services within the environment. But before I do that, as Jeffrey was saying, we want to isolate our different workloads. And in this case, I've got a sales virtual network, which has a subnet of 10.10. We've got another marketing network on the 172 subnet. These are isolated VM networks that don't conflict, they don't communicate in this sense, in this example, they're isolated from one another. These could be different groups within an enterprise or different customers within a service provider. Either way, we've isolated them without the need to use VLANs. We're using network virtualization to achieve that isolation. Let me show you exactly how I've built one of these virtual networks. So I'll right-click, I'll create the VM network, and this is going to ask me for a few different inputs to complete this wizard. So I'll call this one, I don't want to call everything Matt, so I'll call this one HR VM network. Seeing as we've got sales, we've got marketing, we better have HR in there, otherwise it could be bad news. Now I'm going to select a logical network, which is an abstraction of our physical network that helps us position and configure these virtual networks on top. So I'm going to select my particular provider IP network there in the logical selection. Then I need to select what isolation I want. If I choose the bottom option, I'm not providing any isolation. I need to isolate this workload, these HR servers, from my sales and from my marketing. So I'm going to choose the top option. And if I'm using IPv6, I can select that here, but I'm going to stick with IPv4 for now. So this is me saying, okay, when I create this VM network, it's going to be isolated, and it's using the power of Hyper-V network virtualization to achieve that. So we'll go next. And now it's going to ask me for specific VM subnets, like we saw with the sales, like we saw with the marketing. Now this one is going to be the HR subnet. And I'm going to put it, coincidentally, on the same, who'd have thought, the same subnet as was in the sales. And that's intentional, because network virtualization is going to mean that even if I choose the same subnet, it isn't going to conflict. That's the beauty. So we can bring in customers into our service provider environment, and they could all have the same IP address and subnet within their own VM networks. We wouldn't have to have that difficult conversation of, you're going to have to change your IP address, which could be a very, very difficult conversation for an application and for the workloads. So we'll go next. Now this is new, and this is important, because what we want to ensure is any of these workloads, these VMs inside these VM networks, can communicate with the outside world, or can communicate with devices that aren't part of this network virtualization world. So imagine one of the HR servers that's part of a virtual machine network, a VM network, communicating with one of the desktops of the HR admins or staff. We need something to bridge that gap between non-network virtualized and network virtualized. And that's where the gateway is going to provide value. And in the box, in Windows Server 2012 R2, is a production-ready, multi-tenanted, site-to-site VPN for providing just that specific functionality. So you can now connect and bridge between not only physical and your virtualized network infrastructure, but also between your infrastructure and service providers and Windows Azure. So really unifying that through the in-box gateway that ships as part of Windows Server 2012 R2. But there are also partner solutions delivering that as well, from the likes of Iron Networks. So some good examples out there as well. So I'm going to connect up my VM network to a gateway. I'm going to use NAT, and I've only got one gateway, so that's how it's going to stay for now. I'm not going to change anything with the NAT configuration. We're going to go next, and we're going to finish. And that's going to take a minute or two to complete and create that HR VM network. But what I want to ensure is I can help you deploy that gateway quickly so that you can scale out with additional gateways should you need to. And to do that, there's my HR VM network that's created successfully. To do that, we ship in the box in VMM a service template that enables you to rapidly deploy new gateways. Now, what does this service template consist of? Well, it's a Windows Server 2012 R2 operating system. It's got a couple of NICs bridging those networks. And if we look inside at the properties of this particular OS, or this particular service template at the OS level, in the OS config, we can see we specify the settings around the operating system. We specify the identity that we want, an admin password that's consistent. We specify the roles and the features that we want. And it's automatic. It's done for me as part of the template that ships with VMM. So we're really enabling you to rapidly deploy these gateways quickly into your environment to allow you to scale and provide resiliency for this new network virtualized world. Again, reducing complexity, making it simple, making it quick. That's the power of network virtualization, and it's built in to Windows Server 2012 R2 and System Center 2012 R2.
Great. Thanks,
Awesome.
Matt.
Awesome.
So, thank you. Yeah, so again, network virtualization is a core technology, a foundational technology that allows you to take advantage of the three clouds, to be able to run things in one place, move them to another, or to have hybrid scenarios.
When it comes to networking, we've actually been driving there's been a quiet but a very large amount of momentum going on behind what we're doing in terms of networking and network virtualization. Starting with 2012, we introduced our Hyper-V open and extensible switch, which quite honestly, a lot of people were very thrilled about because it provides an easy way for folks to be able to plug into the Hyper-V extensible switch to add in a whole bunch of value and a whole bunch of interesting capabilities. Well, we also have a whole bunch of gateway appliances coming to market now. F5, Iron, Huawei, bringing gateway appliances in terms of our networking partners. We also have OMI-based top-of-rack switch with Arista and others on the way. When it comes to those Hyper-V extensible switch extensions, we've got Cisco, NEC, Five9, Inmont already out there, very excited, more on the way as well, plugging into the Hyper-V extensible switch. And then to take advantage of NVGRE and things that we're doing in terms of network virtualization in the chipsets themselves, Broadcom, Intel, Mellanox, Emulex, Brocade. The great thing about all of these things that we've done is this is all industry standards based. OMI, industry standards. NVGRE, industry standards. So we want to make this very easy, nothing proprietary here. We want to make this easy and as well as very manageable. So when it comes to business continuity, one of the things that we really wanted to do in 2012 with Replica was make business continuity, site migration more available to everyone. Quite simply, talk to way too many people, and it feels extremely appropriate that I'm here in New Orleans having this conversation, because Hurricane Katrina is what really brought this to bear and top of mind to many of us at Microsoft. We saw it hit firsthand. And the thing that, always to this day, it's always top of mind for me with hurricanes and Katrina was, we literally watched it for a week. I grew up in California. We have earthquakes. Earthquakes just hit. There's no warning. They just happen. You just try and find a safe place to be. Katrina we saw happening. We watched it on the news every night. Hurricane Sandy, same thing. We wanted to make sure that we actually improved this situation for everyone. We know that people can rebuild the brick and mortar, but a lot of people lost their businesses and their data. Replica is about improving that situation at a very fundamental level by providing disaster recovery capabilities for everyone. And even those that already have disaster recovery implemented, I talk to customers all the time who say, look, we've already implemented DR, but it's only on a very, very small subset of our core infrastructure. And the reason why we can't expand it further is because we couldn't afford it, or we don't have the networking capabilities to do it. Or we just simply couldn't do it, but we'd like to do that. So with Replica and what we're delivering in Windows Server, we want to be able to broaden your business continuity. If you already have a DR solution in place, a nice high-end synchronous SAN replication, the last thing I'm going to tell you is let's go rip it out. Keep it in there. But let's go expand around that and expand it dramatically with what we're doing in terms of business continuity. So Hyper-V Recovery Manager is about doing that, but it's also about making changes in Replica itself. So there was one key request that you guys had in terms of Replica. So by default in Windows Server 2012, Hyper-V Replica will replicate every 5 minutes. And we chose that as kind of the sweet spot. And the reason why is because we wanted to go after commercial broadband. Okay? It's not synchronous. We went after 5 minutes because, quite honestly, I got colleagues that are replicating VMs between their homes over a cable modem. That's what we were shooting for. All right? But at the same time, everyone came back to us and said, that's really awesome and we love it, but we'd like to be able to toggle that just a little bit. For example, at Microsoft on campus, it turns out everybody's using it all over Microsoft. And because we got these big pipes on campus, everyone's replicating VMs between labs now. So they said, look, we want this to lower this way down because we're moving VMs all the time now. We can move them, say, from Redmond to Seattle, Redmond down to Mountain View very quickly. So we now can go all the way down to 30 seconds. So if you've got bigger pipes, guess what? Replica just goes faster. On the other hand, we've got customers out in the middle of, well, in the middle of Timbuktu sometimes. I've spoken to folks in Australia as well as folks in Africa, and they said, look, our network connectivity is satellite. Okay? It's super dodgy. It'll go down for 10, 15, 20 minutes at a time. Latencies are pretty bad. Throughput's pretty awful, but we still have data that we'd like to be able to replicate. Can you give us a little bit more leeway in terms of replication time? So it can now go all the way up to 30 minutes. So we've given you that additional key capabilities there. And then, of course, there's Azure Hyper-Recovery Manager. That is about providing you that orchestration, that management in the cloud to allow you to manage your replication holistically. So with that, I'm actually going to jump to this demo here. Let me show you a few things. So first of all, let's talk about storage. I've got my SQL server here. I've got a virtual machine. I'm going to go ahead and right-click and go on here into Settings. One of the things we want to do is, look, I've got a SQL database, and when I created this virtual machine and I created this virtual disk, I created it, it's got 70 gigabytes. But you know what? I should give myself much more headroom. I should have actually made this 500 gigabytes, and it's already online. No problem. Simply go here and Edit, click on Next, and let's go ahead and expand this disk. I can now go ahead. It's currently 70. We can make this 100. Done. It will immediately expand the disk live while the virtual machine is running without any downtime. All built into Server 2012 R2. And by the way, you can shrink as well. So it's online grow and shrink with Hyper-V in 2012 R2. Now, in terms of replication, one of the things, like I mentioned, let's go ahead and walk through, let's go ahead and walk through replication. I'm going to enable replication. And I'm going to replicate from this server to Blue 2. And again, we have compression on by default, and I don't need the page file, thank you very much. And you can see here we have three options now. 30 seconds, 5 minutes. I'm sorry, it's 15 minutes. I said 30 minutes earlier. It's 15 minutes. This gives me that extra leeway for long distances, like I said, over satellite, or 30 seconds when I'm on campus and I've got really huge pipes. With 30 seconds, we're near synchronous now. We're still not synchronous, but we're very near synchronous. And again, at the fraction of the cost of doing this synchronous. We know that a lot of people are going to be very happy using our near sync option here with 30 seconds. In fact, I'm going to go ahead and choose that. Click Next, and just like that, I'm done. I'm enabling replication. Now, one of the interesting things about Hyper-V Replica that we enabled in 2012 is we wanted to create an opportunity for our cloud service providers. So, for example, if Jeffrey is my customer and I'm a cloud service provider, I want to say, Jeffrey, you know what? I want you to replicate your VMs to my cloud. Except there was one problem in 2012. Me as the cloud service provider, I also want to use Replica. I want a replica from my site 1 to my site 2. So what I really want is a 3-hop replication. What I really want is tertiary replication. Guess what? We put that into Server 2012 R2 as well. So I want to now go, I'm going to go on over here. I'm replicating to 2. And guess what? I am now going to extend that replication. So now me as the cloud service provider, I'm going to replicate this on over to number 6. And in fact, walk through it. Again, I have the independence. I can set that there. And click Finish. And just like that, I have tertiary replication. So my customer is replicating to me at my site 1, but I'm actually using Hyper-V Replica to also protect and going to my backup site. So that's a key capability that we built right into there. All right. So finally, let's come back over here to Contoso. So if you saw me do the keynote a little while ago, you actually saw me trigger a replication. And in fact, you'll see that all these VMs are stopped. The reason why was because in the keynote, I triggered the replication. I did a planned site migration, and in fact, it's now running on my DR site. So this is actually my primary site, and I did that failover. So let's hop on over to Recovery Services. And again, Hyper-V Recovery Services is my centralized management console to manage my replication at scale. And again, this is multi-site. So I could literally see whether I'm running, Louisiana, New Orleans, New York, Shanghai, Bangladesh. I can see all of these and give me one console to manage all of my DR services. Going here into Contoso Corp. Again, here are the virtual machines that I'm protecting. Here's my sales site. This is the one that I failed over earlier this morning. You can see it's protected. And in fact, let's go ahead. We can take a look at some of those virtual machines. This may look familiar. For example, as we walked through Hyper-V and we were showing you those configuration settings in Replica, well, guess what? They're also here available as well. In fact, let me go right over here to my primary site. So all of those configurations for virtual machines, for example, if I want to set the frequency of application consistent snapshots, if I want to do the initial replication, or if I want to configure the replication start time, I can do all of this. So I could even manage replication for other virtual sites, all centrally managed here through Hyper-V Recovery Manager. Again, this integrates with System Center. So the thing I want to reiterate is replication is still occurring site to site. Azure, living up here in the cloud, does not get any of the replication. You don't want that. You want the replication to occur between all of your sites, point to point. That's exactly what we're delivering in this release. And so finally, I did the replication, recovery plans. I showed this earlier, but real quickly, what's cool about this is, think about when you're doing a site migration or a disaster recovery and you're failing over to a new site, you want to make sure that you're bringing it over in a systematic and orchestrated way. In fact, in the DR world, they call these run books. Well, you can see here, I'm grouping my virtual machines. So here's my backend SQL server, my app here, my web tier, and my app tier. So this tier comes up first. When this tier is done, then this second group comes up. I can bring that up in a systematic way. If I want to add something to this group, go in here into this group, I could add a script. So for example, I could add a PowerShell script to go after the group 2 failover. Or if I wanted to add another virtual machine that belongs in this group, look, it's just super simple. It's click, click, click. And we're creating a recovery plan. It's really that simple. If I want to add a manual action, so say for example, after group 2, I actually need Bob to go into the power closet and I need to go him to turn off breaker number 5 before we continue on. I could say, tell Bob to go turn off breaker number 5, and when that is done, click OK, and then we next move on. So we even incorporate manual actions as part of the recovery plan. And finally, like I said earlier, if you do have to do that migration, and hopefully it'll be a planned one, you simply come on over here into failover, you do a planned failover, you determine the direction, and you check the checkbox. It's really that simple. That's what we're trying to do. As Jeffrey mentioned earlier so eloquently, we try to make the really hard problems, the really difficult ones, really easy for everyone. All right, so with that, I'm going to pass it back on over.
Excellent. Yeah, that's in my mind, one of the most profound examples of the benefit of the 3-cloud strategy, right? Everybody here can afford to buy a couple extra disks to get reliability of your data, right? But how many of us can afford to have extra data centers across the world for reliability? And so our 3-cloud strategy says you don't have to do that. You can take advantage of, you can run your stuff on your site, you can take advantage of service providers, you can take advantage of Azure to give you business continuity. It's a great story. So now let's talk about consistent management experiences. Okay, so now Azure, the design center for Azure is, starts at starts at thousands of machines, tens of thousands of disks. So whereas we use the same technology, hypervisor, management technologies, etc., there are some real fundamental differences between the way the operational model of Azure and some of our service provider and on-premises. So if you're running a Fabric on-premises and we hire you to run Azure, you're going to have to learn some new things. But if you're a customer of these things, if you're a customer or a tenant or a user, you're going to have the same experience across these three clouds. And the way we're doing that is the Windows Azure Pack. This is Azure code, first developed and deployed on Azure, that we're taking from Azure and making available on service provider clouds and on customer private clouds. And what this does, it provides a consistent management API, a REST API, and then a GUI experience layered on top. It gives you a consistent management of your virtual machines, service bus, and of websites. Okay? And with that, let's bring up Michael Leeworthy to give you a demonstration of the Windows Azure Pack.
So excited, that's my problem. Okay. So you saw a little bit of the Azure Pack in the keynote. And one of the big things here is, around operational efficiency and consistency, as Jeffrey was saying. One of the challenges we all have, in working in our IT organizations is how do we increase our operational efficiency by providing, that just simple IaaS or simple PaaS services to our customers. And how do we really take advantage of the capacity that we're building with VMM and Windows Server? Now, the big thing here is, as Jeffrey was saying, we've taken our investments in Azure and we're allowing them, or bringing them into your organization. This is running on your data center, on Windows Server and System Center. It's effectively running on top of that. So it's not a new product, it's just new technologies, new features which you can take advantage of in your current infrastructure. Now, as you saw this morning with Claire, this is sort of the tenant admin view. This is the view that you're going to build for your divisions or for your customers if you're a service provider. And they're going to go and create their websites here. We have high-density website creation. One of the great things is the integration of the gallery wizard. For example, here, if I wanted to create a new website, I have a fully integrated gallery of open source technologies. I also can then provide other gallery items as well. This is fully customizable in the way that you want to provide this great self-service solution out to your either customers, either internal customers, or of course service provider, if you're a service provider. But I think one of the good things here is the service admin view, the back end of this. If you're the infrastructure administrator and the service admin, how do you look at this? And the great thing here is this is where you start taking your infrastructure, your virtual machine manager infrastructure, your IaaS infrastructure, and all those jigsaw pieces, and you put them together into this great self-service solution. So you're seeing here are things like my website clouds. And here's my, the cloud that I built for my website cloud. And I can look at the roles associated with this and view all the servers and associated information within those. So you can see here are all the servers that go up to make my website cloud. I can look at my virtual machine cloud. You can see here, this is just pulling my virtual machine management information in. So I've created a gold cloud in VMM, and I'm advertising that as capable in my Windows Azure Pack solution. Now, what you can do here is you can also then provide these as subscriptions or cloud subscriptions. So all I do is create a plan. So in here, I just quickly go and create a plan. And this idea here is that I'm going to take that infrastructure that I've built, the fabric that I've built, and then I'm going to carve it up for, say, the HR department that Matt showed before. So let's call this the HR plan. And the first thing it's going to ask me is, what do I want associated with this plan? What services do I want on this? And today it's not going to ask me that. Let's give it a little bit of a refresh. We'll try that again. Okay, so we go out and create a new plan. Okay, now we have our websites in. So you can see here, this is my website cloud, my virtual machines cloud. We also provide SQL and MySQL. So this is your PaaS, simple, self-service, simple PaaS solutions and on-premise IaaS solutions for your self-service customers. So in my case, I'm going to choose, say, virtual machine clouds and a website cloud. I'm going to then just go through here. And we also can provide add-ons. Add-ons might be like things like backup, disaster recovery, high availability that I can build on top of this as well. And all I do is go and configure my plan. And this is where I think it's really exciting. So I can go into my virtual machine cloud here, and then I can configure that exact environment up for that division. So I'm going to choose my manager. I'm going to choose the cloud that we saw before. This is coming straight from Virtual Machine Manager. And you can see here I can configure the exact usage limits. So I'm pulling that cloud, and we've gone into Virtual Machine Manager and we've created that fabric with cores, with storage, with memory. What I'm doing is I'm then carving that fabric up for the exact IaaS need for one of my customers or one of my divisions. So I can really provide the great self-service solution. So you can see I can build these plans in minutes. I can build IaaS service solutions in minutes. So if I have the HR department putting a request in, we can actually get this capacity infrastructure built up in minutes for them, give them that self-service experience, and then they can go and deploy all the IaaS solutions they require for their modern development. Now, the last thing that I want to just talk about is some of the great integration of management and PowerShell, since we've got Jeffrey over here, that we've now integrated in this. So we now have a full automation engine that we provide within the Windows Azure Pack services as well. And the great thing about this automation engine is it's actually running on utilizing PowerShell. So you can see here I have a run book. I can actually go and author that. You can see that I'm actually utilizing integrated run book, which I can then utilize Orchestrator and System Center Orchestrator before. So what I showed you is how you can really use the great investments you've used in Windows Server 2012 R2 and of course System Center 2012 R2 to really provide that phenomenal on-premise IaaS and PaaS solutions for your customers or for your divisions in your organization. Thank you.
Wow. Okay, so that's awesome stuff. And that, again, that experience you're going to see across all of our clouds.
All right. So one thing to point out is you've seen System Center used in a variety of different ways. I've used VMM. You've seen it used in a number of different demos here. And we want you to make sure, remember that all of those System Center skills you built up, guess what? They just transfer and they continue to work because we think of this as really our holistic management solution for all three of our clouds. Again, Azure, public, service clouds, private clouds, etc. In addition, we're also announcing we have new Java application performance monitoring. So it makes it even better to provide fantastic, deep, rich monitoring from within System Center. So we have System Center Management Pack for Windows Azure to help you manage your applications, to manage deployments up on Windows Azure. We also have System Center Advisor and System Center Global Service Monitor and to help you to provide additional System Center capabilities. And you can see there's this both symmetry between on-prem and Windows Azure. And of course, Visual Studio are superior development tools out there to allow you to write applications that can run anywhere. And with that, I'd like to actually pass it on over to Simon to talk about application performance monitoring.
Thanks, Jeff. So I'm here today to show you how you can extend your own data center and take advantage of Microsoft's cloud services. So I have a website that's running in Seattle, and of course, being from Seattle, I either make software or I make coffee. So here's my coffee application running in my own data center. But the challenge I have is, how do I really know how well my application is performing from the rest of the world? I want to be selling my coffee to customers located in Brazil, in Japan, all around the world, but I don't really know the performance or the quality of my application. So what we wanted to do is leverage our cloud services, our data centers located around the world, and basically extend your own testing infrastructure. And we do this using System Center 2012 Global Service Monitoring, which is one of the components of Operations Manager. Now, essentially, what GSM does is it allows you to upload your own custom tests that you write into our data centers and then test your applications from around the world. And by custom, I mean your developers can literally write their own web-based tests using Visual Studio, upload them into our data center, and go ahead and actually test this entire environment using your custom tests. Now, configuring it is pretty straightforward. It asks you just 4 questions. What website are you testing? Where are you testing it from? What type of tests are you going to run? And what's the performance threshold that you're looking at? And so it's important to note here that we're just not testing application availability, we're testing application performance as well. So as we go take a look at our dashboard view here, you can see these 16 data centers that I'm actually testing my application that's running in Redmond from. And I can see for the most part it's healthy, but as I look at Sao Paulo, Singapore, and Taipei, I have some problems here. So it's not performing to the level I want. Now, I personally use this in my own testing because I run a lab based in Redmond. When I travel and speak at these different conferences, I want to make sure that we have a good quality experience. So when I went to Moscow, I tested my apps from Moscow before I even flew out there to figure out, will I want to run it from my Redmond data center, or do I need to go and find some local resources? Now, we appreciate that not all of you out there have the ability to have these local resources or these other data centers. And so what we're able to do is actually get performance insight of the application in case you need to send it to a developer for him to go fix it, to go and make it more efficient. So I'm going to go back to Operations Manager. I'm going to go into my monitoring, and I'm going to go open one of my applications here. And we can see that there's already some performance alerts that we've found. Now, as I go take a look at this first one here, the server application performance alert, I get some insight that I can then go and send to my developer. Now, with this information, what we're able to do is go and hand this off and allow them to get deep debugging information that they need. So they can really try to figure out what exactly went wrong, where were my delays in the application. And so as I look at this view, I can see I have a 5-second threshold, and I've clearly exceeded it from the time to the first byte, for the time that my document object model is ready. It takes about 11 seconds for my entire app to be ready. Not so good, but let's say I want to have some more detailed information. Well, what I can actually do with all of these events is go send it over to my developer and have my developer go troubleshoot it, go debug it, right? I don't write the code. I want to hand that over to the experts. And we can save time by directly integrating this with Team Foundation Server. Now, TFS is one of these Visual Studio tools that our developers use for project management. And by immediately sending this information directly to the developers, it speeds up the time to resolution. I no longer have to collect these stack traces. I no longer have to do debugging, right? I just want to run my infrastructure and have my developer look at that code. So simply sending it over to the engineer, it's going to get assigned to engineering. Our engineers, our developers now have the ability to go and debug this and make it more performant to meet these types of goals. Now, essentially what you've seen here is us giving you the ability to run your application globally. No matter where you're located and no matter where your customers are located, we can make sure that you have not only availability, but also the performance goals that you need. Thank you.
Hey, thank you, Simon. Awesome. Perfect. So there you go, an integrated application monitoring system that'll work with your applications, whether they're running on your cloud, in a service provider cloud, or in our cloud. Okay? So it's time. You know, the days of the cloud being a science project that the geeks played around with and had a difficult time with the bent paper clips, those days are behind us. It's really time to adopt the cloud. TechEd here is all about giving you the information so that you can find out what is the appropriate way for you to adopt and take advantage of the cloud. Should you run it on premises? Should you take advantage of service providers? Should you use the Azure cloud? So we got lots of great content on that. We have an Ask the Experts. We brought in the smart guys. They're here for you to talk to, drill in, get some of the details. There are over 20 sessions talking about the new stuff. Now, up here, for some reason, these were all embargoed, right? So now all the details are here. We have cards. They're at each one of the corners here. You can come up and get them, give you the full details. I'll pay particular attention to the 3 o'clock session on mine. It's a desired state configuration. You'll like that one. But indeed, there are also sessions on upgrading. We know that we're going to help you get from where you are to the latest versions of the product. So we've got sessions on that. And thank you very much.
So again, if you'd like to get a copy of all of the new sessions that have come out on Server 2012 R2 and all the new stuff that came out today that was embargoed, please come on up. You can get a card right up here at the station.
Yeah,
thank you very much and enjoy the rest of the week at TechEd.